Hi guys, a very warm good evening to all of you. Can you hear me? Guys, you can ping me in the question bar. So guys, before starting the session, let me quickly introduce myself. So this is Anish. I'm one of the founder of Dataflair Web Services. I'm heading big data practices as well as training here. So a little bit about my past. So I have spent around 17 years in the industry. I've started working on C and Unix, and for past almost 5 years I'm working on big data. Alright, so let's quickly start the session. So guys, the agenda for this session is introduction of big data. Let me use highlighters so that I can highlight the things. Introduction of big data. Then we are going to discuss data explosion. Then we are going to discuss essence of big data. State transformation of big data. Then what are exactly the conventional approaches that were used before big data technologies came into the picture. Then we are going to see what was the actual problems with those conventional technologies. So big data, there was a requirement of big data technologies. Then we'll see the solutions, and finally we'll see the use cases. This is going to be a long marathon session, guys. By the way, at any point of time, if you have any questions, any doubt, you can ask, you can stop me, you can raise your hand, you can put in the question bar. I'm having a small expectation. If you are getting the things, keep pinging me smileys. That would be great. Okay. So guys, starting with very zero, means just from the foundation. So as we are having guys from the diverse domain, diverse experience, guys, few guys are the freshers as well, and few guys, one guy who is having highest experience is 19 years of experience. Okay, but for the big data, everybody is on same page. That's why I'm starting from scratch. What is big data? So guys, if we understand, the data that can reside in the memory or RAM is considered as a very small data. A very fundamental definition I'm giving you. One step by step, we'll go ahead, we'll move to the quite high level. Okay. Data that can reside in hard disk, your normal disk of a system. Data that can be stored within the boundary of a single system, single machine, that is considered as a medium data. Now, data that cannot be resided in a hard disk or it can't be stored in a single system is considered as a big data. Big data, the range will be like more than thousands of GBs. Usually we talk we consider the data as a big data based on various dimension, but in terms of volume, I would say it would be more than some TBs, few TBs. I would say more than few TBs per day. What is big data? Let's see few other definitions of big data. Big data is all about finding needle of values in haystack of structured. Now guys, I'll explain you what is structured, semi-structured and unstructured data. And So let me discuss the same. So guys, structured data is, I'm sure all of you understand structured data. The data that is having predefined format, data that can be stored easily inside conventional databases, RDBMS, that we can imagine that data in the form of rows and columns. We can understand that data as in the form of rows and columns. All of you guys understand structured data? Yes, no? Should I give few more definitions? Perfect. What about semi-structured data? A very simple example of semi-structured data is like XML can be considered as a semi-structured data, or JSON data if you understand JSON, or say for example you're having Excel sheet. We are having lots of there are hundreds of columns in which we are filling 2 columns in some row, in some column 5, in some rows 5 columns. That also can be considered as a semi-structured data. So if I read a definition, data that can be easily converted into structured form after some processing. Okay, Hitesh is saying log files. Okay, log files can, some of the log files like if you are aware of Apache logs, they are sort of semi-structured data, but there are tons of formats in the logs that are machine logs, that are from the network elements in telecoms. So they are purely unstructured. Now, the biggest source of data that is unstructured data. Now guys, this is a very important thing also. Understand it carefully. By the way, before I explain you guys, it's my expectation that you all should have paper and pen ready with you. Keep noting down new concepts which are coming. So if you are not aware of all such these terminologies, you can note down the definitions, although everything, all the materials, everything will be shared to you, but still I want, if you note down, it would be much better for you to learn. Unstructured data, data that is in the form of text, data that we are posting on the social media, post on the Facebook, tweets on the Twitter, videos, images or multimedia, or machine logs, and number of formats of machine logs are there. They are also unstructured data. Now guys, understand one interesting thing. This unstructured data we cannot store. We cannot store this unstructured data inside RDBMS. So in the legacy system, if we talk about all the guys, means if I talk about say till 2007, when big data technologies was not there, or for over last 2 decades, people are using RDBMS. RDBMS means Relational Database Management System, where we are using Oracle, DB2, MySQL, MS SQL, etc. Now, but these RDBMS cannot store, unstructured data. Apart from that, there is another fact. More than 80% of data generated today, more than 80% of the data generated today is unstructured. Now guys, you can understand the requirement. You can understand the requirement of big data systems. What was the requirement of big data systems? So now guys, you'll ask me a logical question. By the way, one guy asked, before big data technologies, how these data were stored. So guys, these data were stored in local file system, not in RDBMS, and most of the data was not analyzed earlier. Okay, Vineet is saying, but these posts are stored on Facebook. Correct, Vineet, these posts are stored on Facebook. Facebook is using big data technologies. Facebook is having big stake of big data technologies and number of big data technologies that we are going to discuss. Okay. Let me take it. Okay, let me take few more questions. Sandil is saying we have enterprise content management system. Yeah, Sandil, go ahead. Correct. So, Sandil, currently this from the EMC only, this that CRMs and content management system, they are supporting some sort of unstructured data. Correct. So recently, by the way, EMC is also a provider of big data and Hadoop. Sandil, actually, the point is that, say for example, if we are getting, say, okay, let me give you a very simple example. If you are having image, if you are having an image that is an unstructured data, but you can store that image in RDBMS easily, right? In the blob clob format, you can store the images. But can you process this image? See, for example, if you want to do image processing, like you want to compare two images and find out the duplicates. If you want to process the videos, let me give you a simple example. Say you are having a video of a store, say Big Bazaar or whatever store you are having video. You want to analyze that video and find out whether there is anything like in the night there is anything wrong going on there, or say find out during the daytime is the store clean or not, such type of things. We can't do such type of processing of this data in RDBMS, in any of the legacy system, even if I should say. Okay, Sandil, got your question? Got the answer? Good. So guys, if I again repeat this definition, big data is all about finding the needle of value in a hashtag of structured, semi-structured and unstructured data. These are the major three forms of data. Okay. Now, we'll discuss one more point. Till if I say approximately 2007-8, before that also there was all the business were running. But what happened suddenly after 2007 or 2008, that suddenly all the people, all the business started demanding for big data technologies. So keep this question in mind. So why exactly big data is required? In next few slides only I'm going to answer the same. Extremely large data sets that are hard to deal with using relational databases. Another definition of big data. Or data that exceeds the processing capacity. Guys, till now I was discussing about mainly the storage capacity. Now another point, data that exceeds the processing capacity of conventional database systems. That is also considered as a big data. Sandil is asking question. I'm not sure if it's relevant. Okay, no issues. You were talking about processing view files, which are basically Sandil, actually it depends. Say for usually, say when I was working for one of the retail client, we were getting the actual video files. We needed to convert them into binary format before processing. So there are a number of video processing libraries are available. Based on your requirement, you can do the same. By the way, when I did, I think it was 2 years ago, for a leading retailer of India only, and we got, they are more than I think 2,000 stores they are having, and 24/7 cameras are running there. And what we needed to find out whether there is any say stores are clean or not, or say at the night if there is any suspicious activities going on or not. So we use a specific video library and we develop the solution in MapReduce. Core MapReduce we used. That is a part of Hadoop that we are going to see, by the way. Okay, good. Let's move ahead. So guys, the what should I say? The major thing is that the main thing is that there is not a single definition of big data. Why I'm giving you a number of different definitions and number of different flavors of big data, because it is just not about the say I'm having 1 petabyte of data, that is big data. No, that's not only big data. I can have say data that is in GBs only, that can be considered as a big data. How? Let's see from the Gartner's definition. Gartner defines big data as high volume. That we understand volume very well, right? Data in TBs, GBs, PBs, high volume. Velocity, the speed at which the data with which the data is getting generated, that is the velocity. And variety of data, that is what we discuss. Structured, semi-structured, unstructured. So Gartner defines big data as high volume, velocity, and variety of information assets that demand cost-effective, innovative form of information processing for enhanced insights and decision making. Guys, why we are doing all such processing, why we are say when I'll explain you big data, Hadoop, there will be having hundreds or thousands of the machines, or there are a number of solutions of the data processing big data. The main reason for the same is the information processing for enhanced insights. The main reason is that we want to generate the reports, we want to generate the insights from that data and help the business to take the better decision. A very important point. I think you should note down this. Now guys, regarding volume, again I'm explaining Gartner's definition as this is one of the important definition. High volume, data in the range of petabytes, exabytes, velocity, the speed at which the data is getting generated, and variety, that is different varieties of data. It needs a cost effective and innovative form of solution for enhanced decision making. Let me take. Yeah, Pratik, I'll give you the example of all these three things. Just wait for a few more slides. We are having dedicated slides for volume, velocity, and variety. Before that, according to IBM, 80% of the data captured today is unstructured. Guys, the unstructured data, that is from sensors used to gather climate informations, or post to the social media, digital pictures and videos, even your purchase transaction records or cell phone GPS signals. These are all unstructured data. This all unstructured data is also come under the umbrella of big data. Let's move ahead. Now guys, if I give you the evolution of big data, so the age, that is pre-relational age. So if anybody is quite senior, so he can if he knows that before relational, there was we were using some sort of mainframes, or we were storing our data in normal OS files. That was a pre-relational age. We were having just primitive type of data. Then from 80s or to 90s, this relational database gave the big impact on the industry. Everybody accepted relational databases. So if I give you, this was like complex relations in the data. Relational database, they were data intensive applications. We got all such normalizations, we got all such concepts of data storage, this primary key, foreign key, and all such concepts. But after 2000, few companies started thinking about the more and more data, like Google, Yahoo, or Facebook. Although quite late, but if I talk about after 2007, almost every company is running behind the big data, because there is a variety of data structure, semi-structure, multimedia. Now today, industry is now data driven. Based on data, you can make a number of decisions. When we will see this use cases, at that time you will come to know what we can achieve with the big data, what with the help of data, what we can come to know. Today analytics has reached to that height that we can answer the questions what will happen. Now guys, imagine I can answer the question like what will be my sales, say being a retailer, I come to know, okay, what will be my sales in next 6 months. That would be great. Retailer can take all the decisions like how much stock he should keep, what type of products he should keep, all such type of decisions he can take. Say for example, what will be his sales in next 6 months, or next Diwali, next Christmas. Such type of questions are now answerable with the help of big data, with the complex data processing. So we are having, in terms of data size and complexity, it's very complex and unstructured data in today's era. A quick outline of evolution of big data, guys, I have given to you. Now let's move ahead. A small glimpse of big data again. So what we are doing in just 60 seconds. So guys, if I take few examples, more than 98,000 tweets on the Twitter. More than 98,000 tweets on the Twitter, 100 plus new accounts on LinkedIn, around 7,000 pictures on Flickr. That's huge. If I give you the example of Google, it's 694. If I take a rough example, 7 lakh search queries on the Google. Huge. If we take in the YouTube, in just 60 seconds, guys, this thing is going on in the on this planet in terms of data. 600 plus new videos are getting uploaded in just 60 seconds, or more than 25 hours of videos are getting uploaded. I'm giving you few sources of big data generation. Apart from this, guys, if I give you a very big image of big data, every day, now guys, it's really very interesting fact, every day we create 2.5 quintillion bytes of data. So much that 90% of the data generated, 90% of the data in the world has been created in just last 2 years. Understand? From 70s to 2013, data generation was merely 10%, and from 2013 to 15, it is 90%. Data generation is exponential with time. It is exponential, you can see. It's quite exponential. Data is growing at 40% compound annual rate, which is reaching nearly 45 zettabytes by 2020. Now you can understand from these two figures that why everybody is running about big data, running behind big data, and why everybody must use big data. Guys, by the way, 2015 onwards, there will be the age of data, and out of which mostly will be the big data. If I give you the example of say organizations who are hunting for big data, guys, it's huge, and the talent that they are getting is very less. There are very less guys are available in the market who actually knows these technologies, because this is still quite new and evolving. Okay, let's move ahead. Now guys, let me give you a few examples of big data generation. Still guys, I'm again and again giving you different facts and figures about big data so that you can understand, you can relate why, what and how regarding big data. Walmart, everybody knows Walmart. Walmart is the leading retailer. Walmart is having 200 million weekly customers across 10,700 stores in 27 countries. It is having 1.5 million customer transactions every hour. I'm having statistics of one of the Walmart's Hadoop clusters. It is having 3 petabytes of data. Just it's one of the cluster, that's transaction cluster, transaction data. Now you can imagine the volume that it is having, and it is processing such volume to generate the insights. Everybody is using Facebook. 4.5 billion Facebook likes every day. 4.5 billion. Guys, Facebook is using Hadoop. Facebook is using HBase, that is NoSQL database. Facebook is using Graph database. Facebook is using Cassandra. Facebook is using n number of big data technologies. 350 million photos are uploaded on daily basis. 250 billion photos are stored by the Facebook. Guys, any one of you have observed that when you say for example when you are using a slow internet connection or at the peak load, when you use Facebook, the profile pic of a guy, of your friend, is getting downloaded very fastly. You can see that quite fast as compared to the photos that he has uploaded. Anybody observed this? Then I'll give you the reason. Okay, just 2 guys observe this. Okay, for rest of the guys, I recommend you to try this again. Open this and close this, then you'll observe that. Sandil Kumar is saying I don't use Facebook. Okay, I was also not using the Facebook recently. I joined Facebook. It's the need today. Anyways, so guys, the reason is that your profile pics are stored in HBase Hadoop, HBase in Hadoop. That's why it is getting uploaded or getting at your side, it is getting downloaded, or you are getting the query result very fastly. If I give you this example guys regarding the photos, now understand the case. If on RDBMS, if I store say records in the millions of the range, suppose say 100 millions or 1000 millions, when I fetch the record, RDBMS requires hours to fetch the records. On the other hand, HBase needs merely few milliseconds. Guys, even Facebook doesn't really need the seconds. It doesn't really need the seconds. We can get that in milliseconds. That's the beauty of HBase. By the way, HBase is the part of Hadoop family. HBase is the part of Hadoop family. HBase is a NoSQL database. By the way guys, please note down this new terms. I think HBase you are listening first time. Okay, Vineet is asking, it takes much time to upload but very less time to download. By Vineet, regarding the upload, firstly usually what happens, the upload speed of the internet users are quite less as compared to the download speed, firstly. Secondly, uploading needs few pre-processing as well. Your pics are getting scanned for various security checks. Apart from that, a number of different checks has been done, then it is uploaded there. Okay, okay, so guys, do you know that? Yes, Andil, go ahead, keep asking the questions, I'm here. $10 billion messages sent every day. the chatting and this messaging that is on Facebook, that is 10 billion per day. Guys, it's like as soon as I am pressing enter, as soon as I am pressing OK or enter, the chat is arrived in my friend's chat box. Again, chatting is on the top, or messaging is on the top of HBase. Okay, so guys, due to HBase, and by the way, it is on the top of Hadoop, HBase and Hive. These are the technologies behind that, due to which it's that much high and that much scalable. There are billions of users now on Facebook. They are doing chatting, uploading, and this. I'm having few questions. I'll take your questions, guys. Just address your questions. So guys, the main reason why Facebook is that much fast, even there are billions of users, the reason is Hadoop and big data. Okay, let me take few questions. Sandil is saying we do have MongoDB, which is also NoSQL database. Correct, Sandil. NoSQL, MongoDB is also NoSQL database. Pratik is saying repeat the definition of HBase. Okay, let me type firstly. This is spelling is HBase. By the way, guys, HBase we are going to discuss little later during our ecosystem. Also, I'll explain you what is exactly a NoSQL database, what is exactly the demand of NoSQL database, where exactly you can use the NoSQL databases, and why it is called NoSQL database. Okay, all such questions. Actually, it will take almost 1 hour for me to explain you. So that's why a different session is dedicated for the same. HBase also NoSQL. What is doing? Sandil Kumar. Okay, let me take one question. Sandil is asking HBase difference between HBase and MongoDB. Sandil, HBase stores the data in the form of key value firstly. By the way, there are a number of differences, architectural differences are there. HBase is developed in Java and it is on the top of Hadoop. And the main thing why HBase is very popular and powerful due to its base, that is Hadoop. Apart from that, HBase is very fast. It's much more scalable. The queries that, say for example, I can have millions of queries per second, read as well as write. On the other hand, MongoDB is not that much scalable. MongoDB is a good solution if you want to store the data in the form of JSON, that is key value format. JSON, all the complete data is in the JSON format, because MongoDB stores data natively in JSON format. Okay, Sandil? Okay, regarding the NoSQL databases, guys, as I told you, we'll discuss in the dedicated session of NoSQL. Let me take a few more questions. Pratik, HBase also will discuss. I think it's after 20 hours we'll see HBase. It would be too early to understand HBase. Vineet is saying FB uses different DBs for different things. Yes, Vineet, it is using a number of different technologies. By the way, there are nice case studies available on the Google for the same. I recommend you to go through that. For its search, it's using Graph database for search. It's using RDBMS also for a number of different purposes. It's using HBase for images. It's using Hive and HBase for this your messaging. There are a number of things. Hadoop, surely a number of Hadoop clusters is there for in the Facebook. By the way, Facebook is having biggest Hadoop cluster on this planet. Okay, let's move ahead. Now guys, there is 1 trillion posts in the Facebook's graph search. 1 trillion. Now you can imagine, guys, the scale that Facebook is having. So guys, currently 3 guys, mainly firstly Google, then Facebook and Yahoo. These 3 guys are at the peak, that huge data as well as huge velocity of the data as well as huge processing. 500 TB of data is getting processed daily. Daily it is getting that much data and it's processing. Facebook is having 100 petabytes of data stored in Facebook's Hadoop disk cluster. 1 petabyte, I'm sure guys you understand, 1000 terabytes. It's huge. I'm talking about Facebook's cluster. By the way guys, Facebook is having multiple clusters for multiple things. Facebook is having if you are aware of Facebook advertisement, the intelligence is again coming from processing on the top of Hadoop only. Okay, perfect time. Sandil asked a question. What kind of analytics do they process for? So Sandil, a very simple example is the advertisement. So guys, I'm not sure whether you know or you have observed about this or not. If I am searching anything on, say, let me give you the firstly the example of Google, same is valid for Facebook. If I am searching for any product, say I'm searching for a mobile phone on the Google, after a few seconds only I'll start getting the advertisement of mobile phone by the Google advertisements. These sites, they are having the Google advertisements enabled. They'll keep showing me the advertisements of mobile phone. Anybody observe this? Anybody? 1 2 3 okay, 5 guys. Okay, fine, 5 of you have observed. Guys, do you know, let me take your name. Say for Vineet advertisement is different, for Pratik advertisement is different, for Sandil advertisement is different, for me advertisement is different. Guys, these advertisements are highly content driven. These advertisements are highly content driven. If I'm signed in and if I'm doing anything, say searching for any of mobile phone or any product, it will keep giving the advertisement. Even if I'm searching for a, say, bus or train or a flight, it will give me the advertisement for the same. If I'm looking for, say, after searching I'm going to Flipkart, it will give me that advertisement of Flipkart as well as Snapdeals as well as XYZ. Guys, this is based on the search keywords, what they are like, what you are liking or not. Based on your profiling, they are giving you the advertisement. Apart from that, they upload all your cookies. Do you know guys, they upload all your cookies. Say for example, on my personal computer, based on my interest, Facebook and Google is giving me the advertisement. By the way guys, whatever I explain for the Google, same is valid for Facebook. Facebook is also providing the advertisement that is highly content driven. For me, advertisement is different. For you, advertisement is different. Guys, even if you are using Gmail, I'm sure all of you are using. If you are using Gmail, then also it is showing you the advertisements, for whatever mails you are getting. Just imagine, say for example, you are getting the mail of say mails related to job. It will give you the advertisement of job. Let me take few questions. Sandal is saying mostly it's on cookies. Correct, Sandal, it's based on your cookies. Apart from that, your search pattern, your search history. All these websites, all these say Facebook, Google, Yahoo, they are uploading your cookies, browser cookies also. They are uploading whatever you have browsed. Based on that, they are analyzing you. They are finding a number of patterns. Based on that, they are providing you the advertisements. Apart from that, guys, advertisements are highly content driven. That's why advertisement cost is quite high in Facebook as well as Google. Vineet is saying that means two persons searching for same thing will get different advertisement. Vineet, it depends on say for your interest. There are chances for the same. So means if you, I recommend you to just do one thing. Say open a particular website on your laptop and on your friend's laptop and look at that. the advertisement will be different. Sandil is saying one thing which may help everyone there. If you are trying to book for the flight tickets, the more you go to the sites and try for the same flights for same day, the cost is going to create. Correct. If you open a new private window, your flight rates will go down. That's perfect analysis, Sandil, you have done. So that's all about a few examples and few discussions about the big data generation. Facebook is always a quite an interesting topic of big data. By the way, guys, we'll see a number of different use cases when we are going to discuss the use cases, guys. I'm sure I'll get a response like wow. Simply, usually 90% cases I get wow response when I give you the difference between conventional technologies and Hadoop big data technologies. Correct, Vineet. Advertisement depends upon the cookies and the of the person that is browsing. Apart from cookies, the search pattern is also involved. Let's move ahead. Guys, now I'm giving you one question. Understand firstly the problem statement. One Boeing plane engine generates 20 TB of data for every hour of flying. Okay, a simple statement. One Boeing plane engine generates 20 TB of data for every hour of flying. Now question to all of you. How much data do all the flights in this world generate every year? If there are 100,000 two-engine flights daily. Guys, think about it. I'm giving you 30 seconds. Try to imagine the answer, the range of the answer. Few answers I got in PB. One guy saying countless. No, nothing is countless, Pratik. Vineet is saying 160000. I can't really count this many zeros. Okay, septillion. Okay. Guys, the answer for this is 6,000 exabytes or 6 million petabytes. 6,000 exabytes or 6 million petabytes. That's huge. That's really huge. Now guys, just imagine this huge data. The airline industry are planning to collect in real time. These airline industries are planning to collect all these data in real time. Why so? We recently got two news. One is from this Malaysian airline, another is from AirAsia. So AirAsia, we got few bodies and all, but for this Malaysian flight we didn't get anything. So guys, in the real time, data will be collected and processed, and it will a number of different reports will be generated, so that if there is any issue, there is any say sort of mishaps or anything that can be predicted based on the weather, based on n number of things, a decision will be taken in real time so that such type of incidents will not happen in the future. Recently, two big incidents. Let's move ahead. Now guys, important thing. Now you are asking about few things, few use cases of few examples of these lessons. We'll discuss now in great detail about these lessons. These are the three essence of big data: volume, velocity, variety. and veracity. So guys, very first point, volume. Volume, we understand very well, huge volumes of data. That is data in the range of terabytes to petabytes to exabytes. Guys, by volume, what I mean? By volume, I mean data at rest. By volume, I want to explain that data is at rest or data has arrived to its destination or data is already arrived at my data center. So if the data is already there, I can easily process that data using the big data technologies. Although data is in the range of terabytes to exabytes, so we surely conventional technologies are not the appropriate solution. Volume, very easy dimension, very easy sense, we can understand very well. Velocity, important point, and today the one of the what should I say, very important this use cases and important researches are going on for the velocity. Guys, velocity means the speed at which the data is getting generated must be same as the speed at which data is getting processed. Both the speed must be same. If the processing speed is slow, we are lagging. So guys, that is called data in motion. We are getting streams of data. If you see stream, so guys, to imagine, to understand, we can take the example stream of water. Similar to that, you can imagine stream of data. Similar to that, you can imagine the stream of data. Okay. Now, what do I mean by this? All such things, guys. Giving you a very interesting use case. I'm sure all of you guys are using now credit cards and all. Firstly, let me ask, how much time does it take for a credit card transaction? Anyone? Correct, Mohit. Hardly 3 seconds, few seconds. If I take few seconds, 2-3 seconds hardly for a credit card transaction. Now guys, understand a case, imagine a case. User is giving his credentials is, and I'm in just next 3-4 seconds at max, his transaction is approved or rejected. In this time, the data will be traveling from client machine going to transaction system. There it is approved. Then after that it will go to analytics system. There it will be analyzed for the risk, for the fraudulent case. Then it will be approved or cancelled, rejected. Now guys, if I want to do fraud analytics, fraud detection, let me give you an example. Okay, at 9 a.m. I am doing a transaction from Mumbai. After 2 minutes from the same credit card, there is a transaction request from Chennai. It means there is something fishy, something wrong. This transaction must be stopped. This transaction must be stopped. Or say for example, usually I do the transaction in say rupees, and there is a sudden request from dollars from any other geographical location. Again, there is something fishy. Getting my point, guys? Such type of fraud cases are happening. So banks are analyzing all the requests, all the transaction requests, and based on the severity of fraud, they are taking the decision. Your algorithm is taking the decision in real time. Now guys, that is called real-time analytics, data in motion analytics. Please note down these terms. I'm expecting that you are noting down these terms. So for few terms, say which are out of the scope, you can do some googling. Pratik is asking, velocity does depends on bandwidth. Pratik, for the bandwidth for which we are talking, that bandwidth is in the range of Gbps. So on the servers that you are submitting, and if you are talking about say persons bandwidth, because what do I mean by Gbps? Let me first explain you. Within the data center, the speed of the network is in Gbps, and bandwidth, if you talk about say flow of data from one end to another end, okay, yeah, bandwidth, it depends on the bandwidth, but velocity, I doesn't mean that the speed of data. I mean that in the real time I can analyze that data. And third point is that there are millions of users who are having millions of dedicated lines from which we are getting the data. Pratik, all of you guys, volume, velocity, is this clear? If I can get a smiley. Although next few slides I am going to explain the same thing in more details. 1, 2, 3, 4. Okay. Still my count goes to 4 only. Variety. Guys, today data is getting generated in many forms. Broadly, 3 forms are structured, semi-structured and unstructured. Especially if I talk about unstructured data, again there are a number of different forms. That is your plain text, images, or apart from that, guys, we are getting the data say in the hierarchical form, in the tree form, that's graph form. So a number of different forms of data is getting generated, and we need an innovative system that can handle all such type of data. Veracity, guys, it is although a minor dimension, but little important. How? Well, veracity means data in doubt. I'm not sure whether my data is correct or not. I'm not sure whether my data is complete or not. There is uncertainty in the data due to data inconsistency, incompleteness, ambiguity, latency, deception, model approximations, etc. By the way, guys, a thumb rule of data warehousing industry: whatever data you are getting is always in the dirty form. We are getting the dirty data. We need to remove the dirtness. We need to remove the dirtness from the data. What do I mean by that? Say for example, data is, there is some noise in the data. There are few bits appended in the data, or there are unexpected forms in the data, unexpected things in the data. So guys, by the way, whatever data we are getting in the data warehouse, whatever data we are getting in the data center, firstly that data will go via an pre-processing stage. We usually process that incoming data, and that particular process called pre-processing, where we check the data, where we say check or filters out. Usually we really don't filter that data, but usually we check the data. That's pre-processing. Let's see each and every of these dimensions one by one. Volume, the massive volumes of data sets, that is in the range from TBs to zettabytes. We understand this very well. Let me go a little quickly. Velocity, the rate at which data is processed should be equals to the rate at which data is generated. My processing shouldn't be slow. Now guys, imagine a case per hour if you're getting 1 terabyte of data per hour. By the way, for one of the client when I was working, a telecom client of India only, by the way, they are getting even more than 1 TB of data per hour from their network elements. That's huge. That's really huge. Now we develop another our own solution. I'll explain how exactly what we did. The processing speed, that is, we converted the data, we pre-processed the data, and final processing and loading, everything was done in real time without a single second of lag. Even I shouldn't say single second, without any lag. Vineet is asking, what does processing of data actually means? Vineet, processing means the conversion of data from one format to another, or crunching of the data, or generating any insights. Okay. Now, third dimension, variety. The data is generated in variety of formats, including structured, semi-structured, and unstructured. We discussed this in great details already. Veracity. The collected data may have noise or abnormality, that is dirty data, which needs to be cleaned before any analysis. Validity. So guys, usually there are 3 V's of big data. So usually in the first round of interview, people ask the questions about 3 V's of big data. Now these last 3 V's also has been added recently in just past year about validity and volatility, although not that much important, but giving you just for your information. The correct data and accurate are intended to use for taking the decision. Whether the data is valid, by the way, validity and volatility are related to each other. So we should supply the correct data for a specific processing. Let me explain with volatility how long the data is valid and how long it should be stored for the analysis. For a specific thing, if the, say for example, if I'm getting the obsolete data, no, my data, that data is not valid. You should give the correct data. Say for example, there is any sudden activity happened and still we are crossing all data and we are not giving the correct point, that point report, correct that point sites. It means that data is not really valid, that is invalid data. Now guys, a deep dive in volume, velocity and variety. Volume. Today we are living in the world of data. Massive volumes of data is getting generated in the range of terabytes to zettabytes. There are multiple sources contributing in data growth. Guys, we have already discussed all such things, but let me give you a few sources of the big data. The data generated by machines, networks, devices, sensors, satellites, geospatial data, and human interaction on systems like transaction-based data that are stored through the years, text, images, videos from social media and so on. So guys, this huge volume of data need to be generated and analyzed. This huge volume of data need to be processed and analyzed for the better decision making. Guys, let me give you the example of, say for example, sensors. If you recall, so before say 2-3 years ago, till if I take the example till 2007, we were not having these solutions. Like we didn't really come to know that okay, if there is any issue that is about to come, if there is any natural calamity about to come. Let me give you the current example. Today, before Hudhud attacked Visakhapatnam, government already knew about the time and the location that Hudhud will strike at Visakhapatnam at this point of time, and government took the preventive action before it really attacked. It's really one of the biggest gift of big data. They are processing with the big data. Okay, Vineet is asking about geospatial data. Anybody knows, by the way, about geospatial data? No one? Senthil? It's about the terrains. Correct. Location. So we need say data about the locations, different geographical locations. Okay. Now let me give you a few use cases of volume. Yeah, you can understand from the GPS also. Volume use cases. Turn 12 TB of tweets created each day into improved product sentiment analysis to know the views of customer for better business. Now guys, let me give you a real use case. When I was working with Disney, Disney is having big user base, big followers on the Twitter. Now what exactly the problem we statement that we got from the Disney. When Disney is launching any product, or even if I give you the general example, say for example any company launch any product or any services, how they will come to know about the whether that product is a success or a failure? How? From the sales data, right? Based on their sales, based on their marketing, their sales increases, and based on their sales data of almost 4-5 months, they come to know about, okay, whether this product or service was good or not, whether people are liking it or not. But say if I'm launching any product, after 4 months or 5 months, if I come to know, okay, there was a big blunder, this particular service, this particular feature of that product people are not liking, guys, it's already too late. It's already too late, because my manufacturing everything unit was keep working for those 4 months, and n number of different, means thousands or millions of pieces has been developed, has been manufactured, right? Say for example for a particular product, people do not like a particular service, or particular things were missing what people were saying. I'll come to know about after 5 months that, oh, people are not liking, there was a very poor performance and all such things. Then I'll get customers this feedback, customers complaints and all. But that is very late. Why? Because already millions of units of the product has been developed. On the other hand, by the way, this was their problem, that what should we do? So when we analyze their n number of types of data, okay, this, that and all, when we saw, okay, they are having huge follower base on the Twitter. Now guys, the day on which they launched their new product, we crawled Twitter, we collected all their tweets related to the same product. On the same day, in the real time, we analyzed all their tweets and we found out, okay, these many people are liking, say for example 80% of the people are liking your product, 20% not liking, 80% liking. What liking? They are liking X feature, Y feature, Z feature. What they are not liking? They are not liking A feature or B feature. All such things are possible with the help of big data. We can process huge volume of data and generate the insights in real time. All of you guys, very important insight, very important use case. By the way, similar use case we are going to use, similar things we are going to use in our project. Let me read few use cases for you. Convert 350 billion annual meter readings to better predict the power consumption. By the way, use case, one of my friend is working in US for the US government. Turn billions of customer complaints to analyze root cause of customer churn. So I'm sure if you know about any of the company who is a customer facing industry, like if you see a very simple example, telecom companies. So currently telecom companies are suffering like anything for the customer churn. Why? Because there is a portability. So people are switching from one operator to another operator, and I'm sure all of you know that people are moving away from companies like Reliance or Tata, and the biggest gainer is Airtel. By the way, we did this analysis for one of our telecom client 2 years ago. So guys, before any guy leave that operator, usually he'll launch at least one complaint. This is a general human tendency, at least one. So we analyzed, by the way, there are billions of customer complaints. By the way, I'm talking about when I was working with TTSL, Tata Teleservices Limited, and we found out a number of root cause why exactly people are leaving their network. So guys, understand these type of scenarios, that with the help of big data, with the help of data processing, with the help of BI, we can help the business in finding the answers of the questions like what, why this is happening, or what or when. such type of questions can be answered, or even we can answer the questions what will, that we'll see in next few slides only. And we can help the business in taking the decision. They can actually take the decision with the help of the same. Now, velocity. So guys, regarding the velocity, if I give you few example, according to Gartner, this definition although I have already given to you, according to Gartner, velocity means how fast the data is being produced and how fast the data must be processed to meet the demand. For example, data is coming in real time with high velocity. On 3rd of August 2013, exactly at 11:21:50 JST, Twitter handled 143,199 tweets per second, or tweets or transactions per second. One figure that came from Twitter. The flow of data is massive and continuous. So guys, if you take the example, say for example, if you are using a mobile application, if you are using that application in the real time, that app owner is collecting the information what exactly you are using and your n number of statistics. Say everybody today uses WhatsApp, so even WhatsApp is collecting all your data about what exactly you're doing, what your a number of your observations or a number of things. Now imagine a case from millions of users. The data is getting collected in real time. So that's a massive and continuous flow of data. And the data must be processed in real time. Now guys, say for example, let me give you a very real time example. If I am using a particular mobile application and I updated that application, there was new update rolled by the company. I updated the application. Suddenly after I update the application, suppose I am using a specific, say HTC Desire 820. On this particular handset, that app started failing. Suppose out of, say there are 500 models, out of 500 models, on 10 specific model, that app starts failing. Now the app owner should take the decision in real time. Even he should get this insights in real time that due to this new update, these many apps started, on this many device app started failing. App is falling down because the data is getting collected in real time, processed in real time, and insights are generated in real time. That's why such type of things are possible. Vineet is saying that means there is no security of WhatsApp. Vineet, there is a security. WhatsApp is not going to sell your data. Don't worry. All your applications, all the applications are collecting the data. Don't worry. If I give you a few use cases. So guys, scrutinize millions of credit card transactions made each day to identify potential fraud. If you want to identify the potential fraud in a use of credit card, guys, by the way, we already discussed this use case, but one thing that I didn't explain that time, that was millions of users are there at that time. Millions of users are there at that time, and I need to analyze and identify in real time. Okay, so this example also we have covered. Take the Google's example about processing of the data. As soon as any blog is posted, it comes into the search result as that at that time only. And by the way, any one of you really do this blogging also? Anyone? So guys, by the way, when I was doing the same in 2004-5, at that time it was taking almost 1 month to come into the search result. When I was doing the same thing in 2007 or 8, I can't really recall, it was taking almost 15 days. but now when I'm posting any blog, it's just taking few seconds. It means Google is crawling the complete web that much intelligently and that much fastly. Sandeep is saying, who provide this analysis, a BI person or technical people like us? Sandeep, by the way, there is a complete analytics chain. I recommend you to do some Googling over the end-to-end analytics chain or analytics life cycle. If you don't really get, let me know, I'll explain. By the way, to provide this insight, this is the work of an analyst. Just to answer your question, this is the work of analyst. If we search about traveling or shopping, that is electronics or apparel or shoes or job, etc., it provides us an advertisement in the real time while the browsing. Even advertisements in the mail are highly content driven. Okay, let's move ahead. Let's talk about the variety. Now guys, variety refers to the many sources and types of data, both structured and unstructured. Now guys, today data is generated in all the forms, like structured, hierarchical data, semi-structured, unstructured. Okay, before that let me take few questions. Sandeep is saying, so what can be done as a technical person? Sandeep, hold for some time. Your question will be answered. It will take some time for me to show you exactly what things you can do and what type of work exactly a technical guy does. Analyst actually uses all such technologies, all such platforms, and all the background work, everything is done by a technical person only. Say for example, development of MapReduce job, data processing, data crunching, setup, deployment, development, everything is done by the technical person, although I'm answering right away only. So just development of the reports will be, say, even that development of the reports usually done by the say if you are doing, say, in the SAP BO, so that BO guy will do. But analyst work is like analysis of the business problem, business analyst, and he will give the requirement, and then end-to-end analytics process will go on. Sandeep is saying he need to know what need to be done. Exactly Sandeep. So guys, there are these many types of data. Structured data we understand very well. That is data in rows and columns that is stored in the traditional databases or RDBMS or legacy systems, whatever name you want to give. Hierarchical data. Now hierarchical data, I'm not sure whether any one of you understand or not. You know guys, JSON data. Okay, good, many of you know. So who don't know, Pratik and Vinita, I recommend do some googling. Okay, let me give one example of this. Let me open Notepad. Say for example, you are getting the data. You are having data like this. Giving you a very simple example. And so on. Okay, so such type of data is considered as a hierarchical data, and data needs to be stored in a specific format. By the way guys, there are lots of say when I was working with a chemical company called BASF, their data, their chemical structure that they need to store, that was itself was in a hierarchical format. So guys, to store the data itself as it is in the hierarchical format, do you know any database that supports this? By the way, Sandhil already answered this. If you can recall, Sandhil. Correct, Mohit. It's a MongoDB. Guys, please note down. MongoDB stores data natively in the JSON format. So if you want to really store the data in the JSON format, you can use MongoDB for the same. By the way guys, again it will be a big question, in which case I can use MongoDB, in which case I can use say HBase, in which case I'll use Hadoop, in which case I'll use RDBMS. So guys, it depends on your requirement. So by the end of our sessions, you will be pretty much confident, you will understand what things you should use in which particular requirement. But just let me give you one insight that will help you a lot. Say guys, all of us are using taking the very simple example of LinkedIn. All of you are on LinkedIn, right? Okay, good. So guys, suppose this is you, and okay, let me take the example, a person A. A person A is connected to person B. My drawing is a little bad, please excuse me for that. Person A is connected to person B and he is connected to person C. What is the relation between person A and B? A and C. A and B will be the first degree and A and C will be correct, second degree. A and C will be the second degree, B and D will be the second degree connections. Or even if I say a very simple example, Facebook, friends of friend. A and C are friends of friend. That is B is the common, right? Now guys, to find out the friends of friend or the second degree connection or associative or commutative relationship between the data. By the way guys, this type of graphs, actual real-time graphs are getting generated. Real-time of graphs are getting generated to find out the associative relationships. Now guys, imagine a case of Facebook where I'm having the data volume of if I give you the user base of billions of users, and now for the billions of users, if I want to identify the associative or commutative relationship of, say, if I'm putting a query in to find out the, say for example, friends of friends or second degree or third degree connections. Guys, firstly, this is really not possible in RDBMS. I'm talking about that scale, that volume. Okay. Firstly, it is not really feasible or not possible in RDBMS. Secondly, if I do the same thing, by the way, for one of our clients, we tried to do same thing in Hadoop also. In Hadoop, it took hours. It took really hours to process this data because the processing is much too complex. You're talking about billions of users, and it would be like billions cross billions cross billions. You're multiplying this many users and then finding out the solution. My God. Now guys, Ketan is asking how about MPP. Ketan, if you're talking, say, let me take the example of MPP. That's Greenplum is a MPP. Greenplum crashed when we really tried to solve this problem. Means for a complete day we didn't get the result back. I'm talking about very big scale. Now what is the solution? What exactly I'm trying to explain here? Guys, if you store this hierarchical or this not hierarchical, sorry, if you store this graph data, this tree type of data, tree structure data in a graph database. By the way, anybody knows about any name of graph database? No one? Let me give you one of the popular graph database, that is Neo4j. So guys, by the way, we used Neo4j only. Neo4j answered this type of question. Neo4j answered this type of questions. Or this type of questions, this specific, this type of question. In seconds of billions of users. By the way, this processing was very complex. What we exactly put for the billions of users, it was around 300 billion test data that we got. And that 300 billion, we found out a number of different relationships between the users. So in Hadoop it took really very long time, even in other databases, because guys, this type means what exactly I'm trying to explain here. You should choose a solution based on your problem. Don't run behind the technology, run behind the problem and solve your problem with a specific technology. Neo4j, the graph database is the best solution. Not only Neo4j, there are a number of graph databases are the best solution for this type of problems. Okay, Ketan is saying I tested with 200 billion rows with query time and something. Ketan, I'm not sure what exactly was your problem statement, what exactly you're trying to identify. If you can help me in get understanding that. So guys, these are n number of different formats of the data, n number of different types of the data. Let me use highlighter. Meanwhile, Ketan is asking. So guys, we saw structured and hierarchical data. If I talk about semi-structured data like XMLs or like Excel data, that is considered as semi-structured data that needs to be pre-processed and converted into structured format. Sorry. Unstructured data like free flow of text, text documents, emails, meter collected data, video, audio, stock ticker data, images, PDFs, monitors, monitoring devices, and number of different devices, logs of a number of different devices are considered in comes in the unstructured data. To handle, store or process these varieties of data from various sources, we need an innovative form of solution that can handle unstructured as well as structured data. So as RDMS cannot handle unstructured data, we need an innovative solution that can handle both type of data. Big data, now guys, veracity. I'm not sure whether this heading goes. Big data veracity refers to the biases, noise, or abnormality in the data. Is the data being stored and mined meaningful to the problem or not? Whether I'm getting the data that is correct or not. Veracity in the data analysis is the biggest challenge when compared to the things like volume velocity, because keep your data clean and process to keep dirty data from accumulating in your system is a challenge, is a big challenge. Let's move ahead. Okay, validity and volatility. Let me go take it quickly. So it is the issue of validity, meaning is the data correct and accurate for the intended use? Clearly valid data is key to make the right decision. Now guys, the point is that if we are using invalid data for a specific problem, if you are generating insights with an invalid data, the final results, final output won't be correct. Say for example, a specific point of time, at any point of time, if that particular situation is correct, you should take that data. So guys, what happens, say for a specific testing, testing for a particular, if I take the example of the retail only. So for we did for one of the app for their apparel sections, we did one of my team did this analysis. They were doing all the analysis on the data that was of the winter, and nobody really didn't find out about that, whether that was a winter data that they got. Actually we got the data, test data from our client, that was a winter data, and we did our complete analysis for the same. So it was almost a big blunder, because we should understand, okay, for which particular season we are doing the analysis, and accordingly the data should be supplied. Volatility refers to how long data is valid and how long it should be stored. So guys, in this real world of in the world of real time, data need to be determined at what point is data no longer relevant to the current analysis. The same example is valid for this particular problem also. Like for particular season it's valid, after that season it's not valid. In the winter, if you are doing the analysis of say rainy data, and also, although this is a very minor thing, very specific to specific domain, not that much related. Let's move ahead. Now guys, specific chain or specific analysis that usually goes, that's transformation of big data. So guys, usually we collect the data. The very first process is the collection of the data. The very first step is the collection of the data. We collect the data, we organize the data. As soon as the data is organized, it is called the information. Organized data is considered as the information. Then we summarize this data. So sorry, yeah. Then we summarize this data. After the summarization of the data, after the analysis of the data, this particular data is called as knowledge. Because we have summarized the data, we have analyzed the data, now we are having the data in the format which can be used further. Now after that, the synthesizing of the data, conversion of the data in the actual reportable format, understandable formats, and the format after which the business can take the decision, that's called actionable insights. That will be the place where decision making. Now guys, if we talk about early 2000s, till that time processing of the data was merely for the information. Say, what was my sales last 6 months, what was my sales last month, last day, last Diwali, this type of analysis was going on. That was merely information to the business. Like, okay, I'll get a figure. Being a senior management guy, I'll get a figure that, okay, being a store manager, I'll get a figure that this was the sale. Beyond which I'll get the figure like what was the sales of in each and every region in different sections and so on. But the main reason about the big data, main reason about the data processing, main reasons behind the big data analytics is the decision making. Help the business in taking the decision at right time in real time. All of you guys 100% clear? If I can get a smiley. By the way, this is a very important point, important concept. Usually people who are actually working on big data, for them also this particular picture is not that much clear. For what or why you are doing, what, when, why, how, all such type of questions must be clear. Sandil is asking organizing the data. Sandil, organization of the data means, say for example, from n number of different sources you are getting the data, right? You will collect that data and store that. Let me explain, give you a real-time example. After pre-processing and post-processing, you'll put the data at the specific in the specific tables, say for example. Okay, say a specific type of data in a specific table, that you can consider as an organization of the data. Ketan is saying, should it be aggregating? Ketan, aggregation and all such things will be done in this from information to a knowledge. That is aggregation, summarization, all such things are done to convert the information into the knowledge. So these are the best practices that usually the big leaders are following, and there are just few deviations, not much, by other players. Ketan, Sandil, clear? Okay, good. Sandil is clear. So by the way guys, the volume on which we have worked recently was in petabytes, even not petabytes a day, from the global 4G player. So at that place we've got all the issues of volume, velocity, variety and all, and the solution was depending on the different problems. For some cases we use HBase, for some cases we use even MongoDB also, for some cases we use Graph database also. That's why I have given you the complete picture, what, where and how you should use and how you should make the decision. Okay, conventional approaches, guys. Conventional approaches, we are pretty much aware of these conventional approaches, mainly RDBMS for the storage. If I give you the example, means whatever I have observed in a number of different clients. So RDBMS is the biggest warehouse that usually where people store all their data. RDBMS means Oracle, DB2, MySQL, etc. And for storage of unstructured data, usually people put the same thing in OS file systems. For the processing, we use SQL queries for RDBMS and custom frameworks for OS file systems. But there are few problems with the conventional approaches. Limited storage capacity, guys. It cannot store the data beyond this some volume. It cannot store the data beyond the limitation of the single machine. RDBMS, let's take the example of the most popular RDBMS, Oracle. Oracle, I'm talking about Oracle's original version that was deployed on single machine. After certain data, after certain volume, you need to archive old data. That's a big pain. That's a big pain in the industry. So guys, if I give the example, when I was working with TTSL, one of our leading client, one of our main client, at that time, means for their specific, by the way, I'm talking about their this UDRs. They need to archive data that is older than 6 months. Archival of data older than 6 months is really huge pain. Now the guy who's from data warehousing can understand very well, because from business you will keep getting the requirement, of processing of the data or reports or insights of the data older than 6 months. What will you do then? You need to load the data back to another system, although you can't really touch your ODS. Limited processing capacity. Since it is deployed on a single machine, so single machine having fixed number of CPUs cores, and the speed of the data processing will always be quite slow. Use case for the same we'll see in use case section. No scalability. So guys, more resources cannot be added on the fly. Like if I give you the example of big data technologies, where we can add all the resources in real time, even we can add more machines in the real time without any downtime. Single point of failure. If the machine goes down, we need to wait till the machine again become up. Sequential processing on the on a single machine, you can't really get the true parallel processing since it is deployed on single machine. Big problem with the RDBMS, it can handle only structured data, and we know more than 80% of the data is unstructured. What will you do for unstructured data then? Apart from that, it requires pre-processing of data. RDBMS needs ETL methods which requires pre-processing of data before loading. Pre-processing of the data, if there is a single byte of data loss, that is not accepted. That's why guys, it is recommended to have ELT methodology rather than ETL. Now industry is moving from ETL to ELT, that is extract, load and then transform. These terms was recently this term was coined by EMC recently, just 7 months ago, that they are started suggesting their client ELT, that is extract, load the data as it is, then after that transform the data. So you will be having the copy of the actual raw data. Okay, Ketan is asking, can you explain single point of failure? I think it is true for traditional. Ketan, for the older version of Hadoop it is true, but for the new version of Hadoop it's not true. It's not really single point of failure. Single point of failure means if machine goes down, you do not have any hot standby, or you need to wait. If your user needing to wait for some time, it means when your machine goes down, if you need to wait for some time, it means it's a single point of failure. And for the latest version, new version of Hadoop, it is highly available. There is no single point of failure issue. Okay. So guys, these are all the problems of big data technologies. Oh, sorry, conventional approaches. What I was saying. These are all the problems of the conventional approaches. Let's move ahead. Now guys, let me quickly read these few slides for you about the limited storage capacity or limited processing capacity. Regarding limited storage capacity, since they are installed on a single machine, they have a specific storage limits. I can store say a few TBs of data. I cannot go beyond that. Yeah guys, I'll take your questions, please hold. Requires to archive the data again and again. The problem of reloading data back to repositories according to the business needs very problematic. It's really very problematic, and only process the data that can be stored on the single machine. What about the data? Now guys, understand the current volume. Say I want to get the trend of last 10 years, last 5 years. Suppose my last 1 year's data is more than 1 petabytes, 100 petabytes. How will you do that? You can't even go ahead with the conventional systems. Vineet is asking about no scalability. Vineet, you understand scalability? What is scalability? We can scale, like more resources can be added. So RDBMS, in the RDMS we can't add more resources in real time. Sandil is asking, do you will you be covering the single point of failure and how it is resolved in new version of? Yes Sandil, it will be covered in our Hadoop session, don't worry. Limited processing capacity, again guys, since it is installed on a single machine that is having specified processing limits, since we are having certain number of CPUs, we will not able to process the large amount of data efficiently on a single machine. Again guys, the use cases or real-time example of these things I'll show in the use case section. Hold for some more time. No scalability. One of the biggest limitation of the RDMS is the no scalability. We cannot add more resources on the fly, guys. This particular thing, you will say wow when I'll show you the architecture of Hadoop. There you will see that in the real time or without any downtime, you can scale your system like anything. You can double, triple, or 10 times or 20 times or 100 times. You can make the capacity of your system in real time. That I'll show you in Hadoop section. Okay. Conventional approaches versus big data approach. Traditional approach, big data approach. In the traditional approach, it was structured and repeatable analysis. That is, business users determine what questions to ask. Business was asking me the question, what was my sales? What was the sales pattern for last year, last 5 years, and so on. And IT structures the data to answer that question. It was like monthly sales report, profitability analysis, customer service, and so on. Now, in the big data approach, it's iterative and exploratory analysis. Here, IT delivers a platform to enable creative discovery. Business explores what questions could be asked. Like brand sentiments, a very nice example. Today guys, every customer facing industry is running for going behind the sentiment analysis. Product strategy, maximum asset utilization, and so on. Let's move ahead. Now let me give you guys a typical distributed system also. Once we have seen the conventional system, that's RDBMS, your OS system, local file system. Now let's see typical distributed system also. We'll be having a SAN, storage area network, and a number of application servers, storage servers. Now programs run on each app server, application server. Here all the data will be on the SAN. Before execution, each server get the data from the SAN, and then it will process the data. After the execution, each server writes the output to again SAN. We understand this very well. It's quite well known. Means they are I think few students they understand, they know from book, and you guys all the senior guys know from your experience. Now what is the problem, guys? This is the biggest problem, the problem that I am highlighting. Biggest problem with this: huge dependency on network and huge bandwidth demand. Guys, if you really knows about the few thing about the infrastructure, the most critical element today in the industry, the most critical element in your data your warehouse is network. You should smartly use your network. So over the years, if you see, so guys, I have used a hard disk when I was in college. At that time it was in MBs, in the range of MBs. Now I'm having the much for my personal usage at my home. I am having 10 TB of hard disk for my personal data. For each and every hardware, for us, if I give you the example of our one of this retail client, recent example, they are having recently the hardware that we got for their deployment. It was having 3.2 TB disk, and there was 9 disk for the same. Oh sorry, 8 disk. Yeah, 8 or 9 disk. So you can imagine volume that the from MBs it goes to TBs, hundreds of TBs now. If we talk about the memory was in even in KBs when it started. Now it's in quite huge. So the biggest system on which I worked, it was having 500 gigs of RAM. Processors also, it was like a very small processor. Now it's having for the servers, people are using 32 64 core processors. But regarding the network, it's still very critical. So guys, being if you really want to become the expert, you should understand, you should really utilize your network quite smartly, because if you are wasting your network, it means the overall performance of your system is going down. Regarding the network, it was earlier also in quite less. I have worked although on the very low speeds. Now also it's quite less, although 4Gs are coming, all such things are coming, but still it's not increased proportional to the other component. Apart from that, scaling up and down is not a smooth process. If anybody really worked on these systems, typical distributed system, he can understand this. It's very painful, and apart from that, it's a little risky as well. Partial failures are difficult to handle. What is a partial failure? Say a specific task, a specific sub job is failed. It's very tough to handle. A lot of processing power is spent on transporting of the data. Guys, as soon as if you see in any system, data transport, data movement, today's world, you can discard that system, easily discard that system. Why? Because we are talking the data that is in the range of petabytes, and movement of petabytes of data, it's really simply a joke nowadays. No. Hadoop, when I show you the architecture of Hadoop, guys, Hadoop is developed in such a way that, by the way, this is one of the most innovative principle Hadoop is having. Hadoop doesn't ask to move any data. Hadoop says, don't move the data. Instead of data, move your algorithm. Say whatever data processing algorithm we are having, move that. Algorithm size of hardly few KBs. Rather than moving petabytes of data, move algorithm close to the data. By the way, guys, this principle is called data locality, that we'll see in Hadoop section. Data synchronization is required during exchange. Surely these are the very big issues that typical distributed systems are having. Why big data technologies? Now guys, conventional approaches or technologies are not able to solve our current problems. They were very good for certain use cases. Today also for the transaction system where you need ACID properties, they are very good. But in today's competitive era, they are not really sufficient to solve all your problems. But they cannot handle the data in the range of petabytes. This is again another issue. What is the solution? Hadoop, the technology of future. So guys, Hadoop is a popular open source implementation of MapReduce, a powerful tool designed for deep analysis and transformation of very large data. We'll see Hadoop and number of Hadoop definition and Hadoop insights later. But first, let's look at use cases, different use cases. So guys, if you have worked on any of the data related product, you can relate your use case or your work with this if you found any similarity. Use case number 1, credit card fraud detection. Credit card fraud detection. As millions of people are using credit card nowadays, it's challenge for credit card companies to identify whether the requested transaction is fraudulent or not. Now guys, to identify potential fraud in a transaction requires innovative form of solution, as time need to complete the transaction is merely 4 to 5 seconds. Data needs to be processed in real time. Guys, we have already discussed the same thing in great details earlier. That's why I'm going a little fast. It is called data in motion analytics. That is, incoming transaction data needs to be analyzed against the individual history, and transaction will be approved or declined based on the severity. So guys, if I give you my own example, when I was using the ICICI Bank, I was connected with my client's VPN. My client's is from the UK. I was connected with his VPN, so I hope you guys understand the VPN, right? So virtual private network, via which I was using his network. Now when I tried to do any transaction, at that time my transaction was declined, and I got a message, a pop-up, that you are doing a transaction from an unusual location. And just after few seconds, just after merely 15-20 seconds, I got a call from ICICI that there was a transaction request from this location of this amount. Was this you? So at that time, yeah, I confirmed that yeah, it was me. Because now guys, that's the severity, and that's the, what should I say, fraud analytics that these guys are doing. Apart from that, another thing that I myself got, when I usually do this transaction, everything from my machine, when I did the same thing from my friend's machine, when I was my friend's place, I suddenly got OTP. They send, although it was not that much severe issue, that's why just to reconfirm they send me OTP. Now guys, just giving you different example. If it's more severe, transaction cancel, you will get a call. Less, you'll just get an OTP, like that. Okay, so we discussed this. Let's move ahead. Sentiment analysis. Again guys, we discussed this in great detail. Let me read this for you. Sentiment analysis provides substance behind social data. It processes language and text to identify and understand customers' feeling, their likings, their dislikings, their attitudes towards the brand or towards the specific topic. Say for example, if a company is launching a new product, using sentiment analysis, we can identify users' opinion about the same, whether people are liking it or not liking, so what they are liking or what they are not liking. Based on users' opinion, product can be improved. Now guys, the main thing is that based on users' opinion, the product can be improved. What do I mean by that? From the same day of launch, I got sufficient feedback that okay, people are not liking service X, I can remove that. People are demanding service Y, I can add that. It enables business to take early decision rather than wait for sales reports, which might take 6 months or 9 months, depends on the business, depends on the nature of business. Okay, let's move ahead. Now guys, I personally worked on this data processing application for one of the retailer. Okay, before going that, let me take one question. Sandeep is asking how education industry make use of big data. Sandeep, so I don't really see much use cases in the education industry for the big data, because big data is more towards solving of huge volume of data, and as far as I worked on this, I didn't saw that much volume that really requires big data. all these problems can easily be solved with your conventional approaches. RDBMS is more than sufficient for this. Okay. So guys, this is by the way, I personally worked on this application for one of our retail client, a leading retail client in India, when I was working with a leading analytics company. Ketan is saying there are use cases around the educational domain. Yeah, Ketan, yeah, they are testing process. There are a number of different use cases, but I didn't really encounter a use case that really needs big data solution. Although a number of solutions for the conventional legacy systems are more than sufficient for that. And if you are having any system, I'll be more than happy to discuss. Okay, let me again start this use case. So guys, for the client, they are getting 100 GB of invoice data daily. 100 GB, not really that much big that we can consider as a big data, but it was big when I show you their requirement. The invoice needs to be transformed into structured format. That needs to a number of pre-processing steps were there, because they need to firstly validate the data, verify the data. Apart from that, it needs a complex business rules implementation. Guys, the thing was that the rules were that much complex that for the conventional approach, I'm saying a very big machine, they were having very big machine, and they are having conventional approach in C, and their processing was done in Perl. So guys, the time taken by them to process the data was 10 hours. It was huge. So guys, when I visited the client, I got when I met the vice president, I got the requirement that their business wants early alert. At 3 a.m. in the morning, they are getting the data. At 3 a.m. they are getting the data. They want, if at 6 or 7 a.m. they can get the sales report, just early alerts. So if I can make this 10 hours to 5 hours, this was the requirement from them. When we develop the same solution in the big data, although we use few high-end machines, we use the cluster, we develop the complete solution in MapReduce, Hadoop MapReduce. Guys, the time taken to process the data was merely 10 minutes on a cluster of 10 nodes. By the way, with Hadoop Big Data, multiple machines work parallelly. That's the back behind logic, that's the beauty. But my client was more interested in the end result. When we reduced from 10 hours to 10 minutes, it was really a huge success of big data technology. By the way, we implemented a number of different solutions on the big data. That retail client currently is running more than 500 nodes on Hadoop now today. It was, by the way, a little old figure of this use case was almost 2 years old. So guys, when I've shown them this solution to my client, frankly speaking, they didn't really accept it, that this is not possible. When we shown them the working demo, then only they really accepted, they realized. And I really got a big applause when we shown them the demo. The mouth of vice president remained open, that yeah, how you made that possible. So guys, that's the beauty of big data. That's what you can achieve with the help of big data technologies. So one of my team and I was the part of that development. Okay, let's move ahead. Okay, so guys, another quite interesting use case from the Sears. Yeah guys, don't worry, I'll give you a break just after 5 minutes. Give me 5 more minutes, then I'll give you a break. Sears Holding. I understand it's a really big marathon session. I also need a break. I'm speaking for almost 2 hours. Sears Holding. Guys, we know Sears is a big retailer who is having worldwide presence. Now, Sears has 4,000 stores with millions of products. Now guys, understand their requirement. It's really interesting. Sears is having 4,000 stores with millions of product and 100 million customer. They have collected 2 petabytes of data. Now the problem is that their legacy system is incapable of analyzing large amount of volumes, large amount of data to personalize their marketing and loyalty campaigns. Guys, all these retailers or from various domains, guys, are trying to personalize their marketing or campaigns or advertising campaigns, so that whatever things a people is liking, say for example, if you are liking a product X, I'll give you the advertisement of product X, not Y. Same as Google and Facebook concept. So guys, their conventional approach for analyzing the data, by the way guys, how will they analyze this? Based on the user's history, based on the user's purchase history, right? So conventional approach for analyzing this data, they analyzed just 10% of the data for personalizing loyalty campaigns on the mainframe, Teradata and SAS. Processing time to analyze this 10% of data was 6 weeks. It was really huge. If you need just 10% of the data in 6 weeks, firstly you do not have the data of last 6 weeks, last 1.5 months, and apart from that you are just analyzing 10% data. They have shifted to big data. By the way guys, this year's holding use case is available on the Google only. I got more insights from actually my friends, they are working there. By the way, this all such insights, nice case studies available. I recommend all of you to read that. By the way, so they have shifted to big data. They have shifted to Hadoop with 300 nodes of commodity servers. Commodity servers are called low-end machines like i3, i5 machines. Now guys, time taken to process the data. Time taken to process 100% customer data was merely 1 week. From 6 weeks, 10% 6 weeks, 100% just 1 week. Look at the difference. Interactive reports can be developed in 3 days instead of 6 to 12 weeks. They saved millions of dollars in mainframe and RDBMS cost and got 50 times or 5,000% better performance. It increased their revenues through better analysis of customers' data. Guys, there are thousands of such type of use cases available in the market, on even on the Google. If I give you another use case, when I was working with another retailer in India, I got a requirement if with the help of big data we can make their stores customer friendly. It's a little weird requirement when I really got such problem statement. What they exactly want, they want that what was their actually thinking, what was their philosophy. If the user is searching for a particular product for quite long, the intention that he will purchase will reduces, the chances that he will purchase that product will reduces, because what happens if, for it's a general human tendency, if I want to purchase, say for example, butter, and I found just in front of my eyes quite easily, I can purchase that easily. So guys, we develop an application that's called Market Basket. By the way, there is another implementation of the same is available in some other formats, but we developed the same thing in the big data. So guys, what exactly we did, based on their historical data, we found out, say for example, a person is interested in purchasing product A and product B. What is the probability that he will purchase product C? If the probability is quite high, we'll put A, B, C together. And based on their last 8 years sales data, we found out the best approaches or best combinations. We put them together, and that gave really good increase in their stores. Sandil is asking, when you get these requirements, do you also set up Hadoop infrastructure or you just do the development? Sandil, it depends on the requirement from the client. If they do not have the current Hadoop infra with them, we need to do all the setup, end-to-end deployment also we need to do. Apart from that, if they are already using Hadoop and big data, we simply do the deployment. So for last 1.5 years I didn't do any deployments, means my team didn't do any deployment. Prior to that, when we are visiting any client for the first time, surely we need to do end-to-end complete procedure. But today people are quite educated in terms of big data. You won't be needing to do much deployments. But by the way, we have added a few dedicated sessions for the deployment during our trainings, where we are going to set up a single node cluster initially. Then after that we are going to set up a real Hadoop cluster also on cloud. Okay, which will give you complete idea that how, what, why we are doing this deployment. Okay, this was the market basket analysis, what I was talking about. Market basket analysis may provide the retailer with the information to understand the purchase behavior of a buyer. Now guys, what happens, this information will enable the retailer to understand the buyer's need and rewrite the store's layout according to the store's layout accordingly, develop cross promotional programs, or even capture new buyers. Now, to increase the sales, supermarkets are trying to make store more customer friendly. By analyzing users' buying pattern, they can identify what are the items they bought together. Why it is called market basket? Because we are analyzing a basket of the customer to make sure customer friendly, to make our stores customer friendly. These items can be put together and relevant campaigns can be run to attract new buyers. Guys, like say for example, if you can see, okay, people are purchasing butter and milk together or butter and bread together, so you can provide them the offer like there is off if you purchase these together. So your current users will surely get benefited, and apart from that, new users will be attracted. And if you put these items together, again the probability that people will purchase will also increase. Okay, yeah. So guys, regarding this big data introduction, although it was not merely just an introductory, we have covered big data, what is exactly the big data, and number of definitions of big data, and number of essence of big data, data explosion, transformation of big data, conventional approaches that included RDBMS, OS file system, as well as distributed systems. Then what were the problems associated, then illustration of solutions. Apart from that guys, we covered real life use cases also. So before I give a break, if anybody is having any questions, any doubts. Once this is over, we'll take a break, then we'll start Hadoop introduction after this. So guys, you can ping me your questions if anybody is having any questions. Okay, continue. So guys, I have pinged you my email ID. You can save this. By the way guys, just after this question hour, we'll take a break and then we'll start the next session, next part of the session. So guys, no questions, all things are clear. If I can get a smiley, if everything is clear. Since I can't see your faces, I can't do face readings and I can't get the answers directly. That's why I'm again and again asking for the smileys. Okay, Vineet Kumar is asking about Greenplum. Vineet Kumar, Greenplum is big data solution that can handle only structured data. It is developed on the top of PostgreSQL. This is another product from EMC only. By the way, Greenplum earlier was a different company. EMC purchased that. Then Greenplum is not that much good for huge volumes, but yeah, it is a good solution for the moderate volume of data. So Sandil is asking, will you covering how it came into play, who created it, and so on. Yeah, Sandil will create, will do all such things. We'll cover all such things just in next session only, in just after next section of the session. Sandeep is asking what kind of job market for this is in India. Sandeep, job market is at its peak. Means say if I take the example of in terms of pays, if you ask me, a normal Java guy, 2 years experience Java guy is getting a salary of say 4 lakhs. 2 year experience Hadoop guy is getting a salary of around 9 or 10 lakhs. In terms of currently how many jobs are there, so guys, currently when I was part of my previous org, it's by the way it's a leading analytics company whose rank was in top 5 on this globe. We were searching, we were hunting guys like anything. When we had the requirement of 100 guys, we hardly got 10 guys. Currently there is a demand of more than 1.5 lakhs deficiency in alone in US, and across the globe it's very huge. By the way guys, by 2015, by end of 2015, according to Forbes, world's 80% of the data will be in Hadoop. So since people are migrating from conventional system to Hadoop very fastly, the requirement is increasing like anything, firstly. Secondly, you understand this can handle all such type of data. And apart from that guys, even myself, I have when I was part of this analytics company, I have done, if I include my team, we have replaced conventional system in 47 clients. 47 of our clients left their conventional systems and they moved to Hadoop in just last 1.5 years. So requirements are like anything. By the way guys, I was also 5 years ago, I was also Hadoop architect, Java architect. Then I shifted to Hadoop. Now it's almost 5 years. Seema is asking, sir, how Hadoop is going to help me? Seema, so I'm having few freshers also with me by the way guys. So freshers guys, in the previous batches also there was freshers who attended training, internships and all. I'm having lots of records by the way. A few of them I have posted their video also, but I recommend you to go to our video YouTube channel. There you will find the video. One of the guys placed in leading investment bank with a package of even I shouldn't disclose the package, it's very high package. Usually it's 4 times what average student gets. People are means Hadoop is like an exceptional skill in your resume if you are able to do that, if you are able to capture. It's a big plus. Means if you really understand, if you get a chance to work on a real life project, it's a big plus. By the way guys, for other guys, senior guys, we are I think alone. I didn't see much advertisement or any other guy who is providing real time internship in big data. So by the way, we are also hiring the guys. Exceptional, as I'm little choosy currently, at least just hiring exceptional guys, extraordinary guys. They will get the chance to work directly with me also. Anybody is having any other questions, any other doubts, anything? Okay, no issues. Guys, let's take a break. Let's take, although it's quite long we are discussing, let's take a break. It's 10:15 around, so let's take a 15 minutes break. We'll start at 10:30 and I'll give you an introduction about Hadoop. Vineet is asking what is MPP. Vineet, it's massively parallel processing. Greenplum is an example of MPP, by the way. There are few students who didn't really heard about these type of terms. I recommend you to note down the terms and do some googling for the same as well. Mohit is asking, I'm having 20 years of experience. Yeah, Mohit. I want to start my own. That's great. So guys, Mohit want to start his own big data company. He's joining us for the same. By the way, Mohit, where are you currently located? Okay, you are in Bangalore. Okay, fine. Okay. Yeah, Mohit, surely means it would be really my pleasure that with the help of our training, you will be successfully open your big data consultancy or whatever in whatever field you want to go. So we can discuss, by the way, for possible engagements also. That's really great to have in this session. Ketan saying, have you explored IBM Netiza? Not really, Ketan, not much worked on Netiza. Yeah, Netiza, just heard about few things about this. Okay, let me mute myself. I'll be back in by 10:30 sharp and we'll start the second section as people are requesting for the break. Yeah, sure, we need. Let me also drink water. Okay. Alright, so guys, after the break, let's start the second section of the day, that is Hadoop. Hadoop, a soft introduction. So guys, today we are going to see the basic introduction of Hadoop. So I'll show you the agenda. So today we are going to see Hadoop introduction. We'll see its basic architecture, then a big question, why. So guys, usually I always take why. You can make this a note that always you should ask why about any technology or any work, why you should do that or why this technology. Then HDFS, MapReduce, so after HDFS we'll see MapReduce, then we'll see Hadoop daemons, how Hadoop works, end-to-end flow of Hadoop, its characteristics. There are different flavors, different distributions of Hadoop currently available in the market. Then we'll see the Hadoop ecosystem. Okay, let's start with Hadoop introduction. Guys, Hadoop is an open source project from Apache Software Foundation. Yes, it is open source. It means its source code is open. Not only it is free, it's surely free, but its source code is also open. So guys, it's really providing you a nice opportunity. We also got this opportunity almost 1.5 years ago, when certain functionality of Hadoop was not fulfilling my requirement for a particular project. We simply downloaded the source code. Changed it according to our requirement, deployed it. So guys, that's the beauty of open source things. But Hadoop is not only coming in the open source format, it is coming in as a commercial or proprietary format also from the companies like IBM, EMC, Cloudera, Pivotal, EMC or Pivotal, right? So it is by the way, the vanilla is from Apache. The base version is from Apache. Now, important point, it provides a software framework for distributing and running applications on cluster of servers. Hadoop is a software framework for distributing, guys. It distribute the work. It distribute the work on the cluster of servers. What do I mean by cluster? Cluster means multiple machines connected together. Multiple machines connected together is called cluster. Sandal is asking, will you show building from this? Sandal, we have not included this in the development in this particular course. There is a tutorials available over the Google. You try that, and if you face any issues, I'll help you. Okay. Hadoop is inspired by Google's MapReduce programming model and its file system, that is GFS. Guys, Google has published a paper in 2004 when Doug Cutting and his team was working on Nudge search engine. They got this similar requirement that under the Nudge they want some similar thing, similar framework, same as what Google was using in early 2000s. So this is how the idea came from Google, and Doug Cutting and his team at Apache started working on Hadoop. Originally, Hadoop was the sub-project of Nudge. It was a sub-project of Nudge, but due to its power and popularity, soon Hadoop became the top-level project. By the way, guys, Hadoop is very powerful. By the way, it is developed by the top-notch guys of the industry, top-notch talent of the industry. Most of its code came from Yahoo and Facebook. Yahoo, Facebook, Cloudera, IBM, these guys have done the most of its development. So guys, Hadoop is developed in Java. Hadoop is open source framework that is written in Java. It's totally written in Java, but you can code in language other than Java, that is C, C++, Perl, Python, Groovy, Ruby, etc. But guys, although Hadoop is providing you the functionality, you can code in another language, but it's recommended that you should code in Java. You should start developing or MapReduce job. You should develop the MapReduce job in Java. Why? So guys, with the Java APIs, you'll get the utmost control. You'll be having the lower level control on the data, on your complete flow. You'll get the complete APIs. That's why it's recommended to code in Java. Now, it efficiently processes large volume of data on a cluster of commodity hardware. So what is commodity hardware? Anybody knows? Before I explain how exactly it is. Yeah, Sandil, a normal sort of PC or i3, i5 machine or cheap hardware. Correct. So guys, the example that I gave you for the retail company, that the client is having his own machine, they were taking 10 hours to process the data. They were using very big monster systems. They uses the specialized system. Guys, by the way, usually in the industry, in all the productions, people use specialized systems. But with the Hadoop, you can go even for the commodity hardwares also. Yahoo is the first entrant who started using commodity hardware and successfully deployed large clusters. I had a news when I interacted with the guy of Yahoo in 2012. Yahoo was running 54,000 machines for Hadoop. 54,000 machines just for Hadoop they were running. So guys, it efficiently processes large volume of data. Hadoop is used just for the big data, huge volumes of data. On cluster, Hadoop works on a cluster. It doesn't work, you can't deploy Hadoop, say if you want to process a petabyte of data and you deploy on a single machine, no. But Hadoop can be set up on a single machine for your learning, testing, R&D purpose. You can set up Hadoop on a single machine, but real power of Hadoop comes with a cluster of machines. It can be scaled from single machine to thousands of nodes on the fly. Now guys, this was the scalability that Hadoop is providing. Since Hadoop can work on clusters, or Hadoop usually works on clusters, I can have, say for example, take the example of Sears, they moved to 300 node clusters. And now their customer base is increasing, their clients are increasing, the products are increasing, now their requirement is increasing. Now with time, they want, okay, with 300 nodes it's not sufficient, they can add more machines, they can scale their system or add more machines in the real time without zero downtime. With zero downtime, I should say, without any downtime. the main funda, the main thing is that, guys, the user, the end user, the end analyst, or whoever is using the system, it would be transparent for him, or he won't really feel any addition or removal of any machines in the from the backend. Now, guys, Hadoop consists of two key parts. Please note down these two names. First is the HDFS and second is the MapReduce. First part is the HDFS or Hadoop Distributed File System. Hadoop Distributed File System. And second part is MapReduce. HDFS is the storage layer of Hadoop, and MapReduce is the processing layer of Hadoop. By the way, guys, Hadoop is that much popular due to MapReduce. That's why MapReduce is called as heart of Hadoop. Let's move it. So a question, why Hadoop? Guys, Apache Hadoop is a platform for data storage as well as processing. Hadoop is providing you two features. First is the storage that is very reliable. So today on this planet, Hadoop HDFS is the most reliable, most fault tolerant storage system. Hadoop is pretty much scalable. It's fault tolerant. What do I mean by fault tolerant? Anybody understand what is fault tolerant? Sandil is saying even if there is any error, it can still continue. Perfect. If there is any fault, there is any issue, there is any downfall, Mohit is saying if any system goes down. Correct. If any machine goes down, then also it will keep working. The system will be up. Your system will not break. Perfect. So today two guys are answering, mainly even I would consider Mohit answered almost all the questions. By the way, guys, let me in between only let me answer, give you one. Usually what I usually provide to all my students, another offer or another thing, I should say award. I provide to the best student of the batch. That's the award I usually give to the best student of the batch. I usually give him say, by the way, the criteria would be the assignments, the answers that he is giving to my questions, and apart from theoretical, the practical assignments. Okay, these are the few things. So the award, student of the batch award, would be he will get chance to work with me on a real life project. I'll give him on end-to-end work of real life projects. Sandal is saying BMW car. So let's see who will get this opportunity. So that would be the really great opportunity, working on a real life big data project. And let's see. So guys, I want all of you to be in the race for the same. So today I can't take any name because today it's the first day. So with time I'll keep giving you the ranks who all is there in the race. Okay, so Hadoop is scalable, it's fault tolerant. I gave you the small definition of fault tolerant. We'll discuss in great detail in this specific HDFS session, and it's open source. So before discussing its features, let's see the core component of Hadoop. HDFS, Hadoop Distributed File System. It's distributed storage and data protection across physical servers. MapReduce. It's distributed computing across physical server. Two components, HDFS and MapReduce. By the way guys, we are having a dedicated session for HDFS where we are going to do a deep dive in HDFS. For HDFS we are going to spend almost 5 or even 6 hours, and for MapReduce we are going to spend almost 15 hours. Today I'm just giving you very basics, so understand the basics. Now Hadoop has the flexibility to store and mine any type of data. Now guys, the question of why Hadoop, three things I have answered and 2 of its components. Unlike RDBMS, Hadoop has the flexibility to store and mine any type of data, ask questions across structured, unstructured data that were previously impossible to ask or solve. Hadoop is not bounded by a single schema. Hadoop excels at processing complex data. Scales out architecture divides workload across multiple nodes. Since here we'll be having multiple nodes, distributed processing will provide an added advantage. So it would be like, instead of one machine, hundreds of machines are working. Surely my work will be almost 100 times faster. It is flexible file system that eliminates ETL bottlenecks. We can have ELT system. By the way guys, with the Hadoop only ELT terms came into picture. That is, you can extract the data and load before any transformations. Hadoop scales pretty much economically. Guys, another reason of Hadoop's popularity, its economic nature. Usually say if you go to any client and ask for, say, provide me 100 machines, then I'll solve you this problem, he will throw you out. So because 100 specialized machines very costly if you ask about specialized hardware. On the other hand, if you talk about, okay, commodity hardware, if you can deploy it on commodity hardware, anybody will be more than happy to give you the same. So by the way, people are deploying Hadoop on commodity hardwares as well. Open source platform guards against vendor log. Guys, it is open source. There is no vendor log. So the guys who can understand from where they are getting any issue from a specific vendor if the services are not good or anything. The point is that you can get the services from any vendor. You don't need to purchase the license. Okay, perfect. A good question from Ketan. Ketan is asking how it scales economically. Ketan is saying, suppose if my data needs increase but compute is same, I have to buy both compute and data capacity, and vice versa. Correct. Ketan, you have multiple options. By the way, usually in real scenario, what happens if your data increases, surely your compute requirement also increases. Why? Say for example, you're having a 20 node cluster and there you are having suppose 100 terabytes of data. To process the data on your daily requirements, you are taking 1 hour, but your data is increasing from 100 TB to suppose 150 TB. Now that 1 hour will become 1.5 hours or 2 hours based on your processing, or I'm giving you random figures. So to keep the SLAs, to keep the processing time same, your compute requirement also increases. So in real time usually it goes together, but if there is a such case, for the storage requirement you can add more disk on the same machine, although not recommended, but if you guys are still adding the more disk, you can add those disks, and to do the configuration, it's merely one file where you need to change in the configuration file, but in actual scenarios they usually goes together. And usually people are going ahead with the 8-core machines, 8-core machine, 16 gigs RAM and TBs of hard disk, which is very cheap machines. So I have worked on the biggest machines, 500 gigs RAM type of machines. Those machines are specialized hardware got from HP on the special request or from IBM on the special request. They are very costly as compared to, means if I divide such resources, say out of 500 gigs machine RAM, if I take 100 machines of 555 gigs RAM each, the cost of 100 machines will be almost 15 to 20 times cheaper than that single machine. Okay, let's move ahead. Guys, it is a very basic architecture of Hadoop. It's very basic architecture of Hadoop. Before that, let me take a few more questions. Ketan is asking, but it is not proportional. Hadoop relies on minimum 3 times of replication. My 1 TB of data gets replicated to 3 TB at least. Ketan, it depends on your requirement. You can change this 3 times to even 1 time also, or you can increase this 3 times to 5 times also. By the way, this storage requirement, usually what happens that proportional to CPU, we are having quite huge disks, right? Say on a 16 core machine, I can put TBs of disk. So such type of scenario, if you see, not all the data every time you will process, not really. And if my data is distributed, so you can imagine my data is distributed. Say if a user is copying a file, he can some part of the data here, some part here, some part here, some part here, and so on. So such, if user is submitting any algorithm, any processing, just that part of that data will be processed here, the part of file will process here, and so on. By the way, I'll explain the same thing in great detail with some animations also. Let's wait. How you reduce it to 1 time? I think it's 3. No, Ketan, 3 is not the minimum. 3 is the default value. It is called replication. Wait for some time, I'll show you. The file, the configuration file for the same is hdfs-site.xml. Let me ping you the same. So recently for one of our client, we reduced this. You can do, by the way, usually in the production it depends on the requirement, depends on a number of factors that we'll see in the HDFS section on what factor it depends. But we did this for say 2, or even we increased this to 8 also for one of our client for a very big cluster. Now guys, this is how actually Hadoop looks like, Hadoop cluster looks like. Although for the simplicity of the figure I have not shown a number of different things, but the main thing what I am trying to explain you here, we are having a master and slave concept here. Hadoop works in master slave fashion. When user submit any work, understand this guys, when user submit any work, master in turn submit the same work to the slaves. In this manner, suppose if I am having a 100 node cluster, so being a work submitted by the user, parallelly 100 slaves start working. Obviously my system, my work, my processing will be 100 times faster. So guys, if I give you if I compare the same thing with the traditional system, there I was having just one machine, right? This was the system there in the Oracle. Suppose user send the request, this machine does all the work and it send the response. It was there in the Oracle. Now what happens? User submit any work, master send the same work to all the slaves. One part of work. Suppose I am having 100 slaves, so if I give you idle condition, so 100 will be done by this machine, 100 by this machine, 100 by this machine, and so on. In this manner my processing will be almost 100 times faster, although there are few factors and number of different things, that's why I'm saying almost. Now guys, you'll say what master does. Master doesn't do actual work. Master's work will be the coordination, management, and all. We are having the concept of secondary master that keeps pulling the data of the master. We can have multiple masters together, like hot standby, like multiple masters parallelly working. All such things are possible, that we'll see in the later sessions. But currently, why Hadoop is that much fast? Why Hadoop is that much? If you recall, from 10 hours we reduce it to 10 minutes. How? Hadoop is not doing any magic. This is a very old concept of distributed processing. Pratik is asking, it send the same work or it divide the work to the slave. Pratik, actually, conceptually, if I say, it divides the work, but in actual processing, what happens that it sends the same work actually. That I'll explain you. Just wait for a few more minutes, then you will get understand of how exactly it sends the same work, and then also that will be sub work, because that depends on the data. So after HDFS, I'll explain you the same. Guys, all of you guys, if I can get a smiley, all the things are clear. Just basic architecture, few things I shown here. Master slave concept. How exactly users submit the work and slaves come into the picture. Okay, we need Pratik, Sandil. Where are rest of the guys? Ketan, Madhumita, Manish, Sandeep. If I can get a smiley, if all the things are clear. Okay, perfect. Let's move ahead. Guys, giving you a brief of HDFS, that is Hadoop Distributed File System. Okay, it is a distributed file system designed to run on commodity hardware. Guys, if it is designed to run on commodity hardware, it doesn't mean that it can't run on a specialized hardware or a high-end hardware. It will surely work pretty well on high-end hardwares as well. HDFS is highly fault tolerant, distributed, reliable and scalable file system for data storage. Guys, all these terms will discuss in HDFS section. So, but just for this, HDFS provides high throughput access to application data and is suitable for applications that have large data sets. Now guys, usually all the applications are dependent on the rate at which the base system provides him the data. Another very important feature of HDFS is that it provides very high throughput of access, very high throughput, so that my application is not limited with the data availability or data rate the underlying file system is providing. Now, HDFS is developed to handle huge volume of data, that is large files in the range of GBs to TBs. Now, a file is split up. Guys, understand this is a little tricky concept, although we'll cover the same thing in HDFS, but for you to understand this, I'm explaining here as well. A file is split up into blocks. Suppose you are having a very big file. Suppose you are having a big file, suppose of 1 TB. The file will be split into small blocks. The file will be split into small blocks. The default block size is 64 MB. The default block size is 64 MB. And it is stored distributedly. It is stored distributedly across multiple machines. Now, master is called as name node and slaves are called as data nodes. Okay, let me take few questions before this. Sandal is asking, if master is down, and secondary master is also not working, how can users submit data at a single point of failure? Sandil, you are giving two conditions at a time. If two people are down, that's not a single point of failure, right? Say for example, by the way, we can have multiple masters. Let me answer in another way. We can have multiple masters, that is more than one master at a time. So say for example, master, if I am having three masters, okay, let's take two master example, one master and second master. Second is my suppose hot standby, and if first master is down, second master will take over automatically. It will take over, right? Now if you see both are down, surely you need to wait until unless anyone will become up. We need such as scam. So till then user cannot do anything. Right, Sandil, how user can do anything in that during that time? No, actually this is not a demerit. This is not any issue with this. It's really not a failure. It's already high available. It depends on your planning actually. It depends actually on your planning. Say you need to identify at any point of time how many machines or your master can go down or not. By the way guys, one important point here I should mention. Your master shouldn't be commodity hardware. Master is a high available machine. Usually we deploy master as a high-end machine. Okay, so there are a few other things that we need to consider while choosing master's hardware. If I give you a few more things, like master should have little higher memory because master stores metadata. All such terms we'll discuss in HDFS session. I think it would be a little early to discuss. Okay, Sandil and Vineet, clear? So guys, understand this. With this animation I'm trying to explain you few things. Requirements of master. Vineet, as I told you, we'll discuss the same thing in HDFS session. Hold for some time. Sandil is saying how will the data come into the HDFS? Just showing you the same. Look at this. So guys, I'm having a very large file. Look at this left hand side. I'm having a very large file. A file say employee data.txt whose size is in say terabytes, 100 TB file. When user want to store this file, he need to interact with the master. This suppose client will interact with the master and do all such things. Firstly, your file will be splitted into small pieces. Look at this. Block 1 of 64 MB, block 2 64 MB, block 3 64 MB, and so on. Then these blocks will be stored distributedly. Look at this animation. This block will be stored distributedly across multiple machines. Block 1 here, block 2 here, block 3 here, block 4 here, and so on. So of 100 TB's file, a file of size 100 TB with block size of 64 MB, there will be thousands of blocks. So suppose few hundred blocks here, few hundred here, few hundred here, few hundred here, and so on. All of you guys, is this clear? How exactly data is divided and stored distributedly. Now, not only this, apart from this, usually multiple copy of data is created. By default 3 copy. Look at this, like block 1 is available here as well as here. Block 2 is available here as well as here, and so on. So by default it's 3 copy, although I'm showing you 2 copies. So block 2 is here, you can imagine like that. So at any point of time, suppose this machine goes down. That is important point. At any point of time, if this machine goes down, from where you will access block 1? You can easily access block 1 from this machine. Now you will say, how will you come to know? Master will have all the information. Master will be having all the information. Okay, so Vineet is asking, is this necessary that all the slaves will work or some will remain at rest? Vineet, this intelligence the master will be having. It is necessary all the slaves will be doing the work, and which block where goes or where how many blocks will go, all such decision will be taken care by the master. Sandal is saying, if you have to process 1 petabyte of data, how much time does it take to load it into HDFS? Sandal, this question's answer of this questions will be, it depends. It depends on the location of your data, it depends on the network bandwidth, it depends on the hard disk that you are using. If you are using say SSD, solid state drives, so it would be very fast. If your network speeds in Gbps, again it would be very fast. Or okay, it depends on a number of different factors. So anybody can't give any concrete answer that this minutes, this many seconds, and this many milliseconds. Guys, is the storage of data clear, all of you? How exactly data is divided, blocks are created, blocks are moved to the multiple machines, parallelly distributedly stored, and if machine goes down, data can be accessed from somewhere else, as we are having multiple copies of data. So if the replication factor is 1, and if any machine goes down, we are going to lose the data until that machine will become again up. Perfect, Ketan. Exactly, this is the reason of the replication. But if you are pretty much sure that you will be having at a time just one machine can go down, that is your SLA, then you can make it to 2, or such hardware decision based on these factors you can take the decision about your replication factor. Sandal saying, but if it takes too much of time when the data may be relevant sometimes, right? Sandal, actually this would be very fast. As I told you, the network between these machines are quite high. Usually the bandwidth is very high in these machines. That we'll see. By the way, in HDFS section I'll show you how it is pretty much parallel as well. It's not like it's just sequential, like first just one block will go, then second block will go. No, it would be pretty much parallel. Let me erase all drawing. Okay, Sanil is saying, which process split the file? It happens even before we submit the job to master. Sandil, still we didn't discuss about submission of the job. Still we are talking about the map, this HDFS, not map reduce. HDFS means storage of the data. HDFS means storage of the data. Now you'll ask, who will split this file? Your client will split the file. So your Hadoop, your framework will split the file. Say the Hadoop setup you are having, that is only going to split the file. These APIs are having the complete code for the same, and from where it will come to know what will be the block size, it will be having the configurations file for the same. Okay, let's move ahead. Let's discuss about map reduce. Okay. No, Vinith, it's not like anonymous. Nothing is anonymous here. Your framework will do that. Don't worry. Ketan is asking, the data is stored in HDFS is accessible only using Hadoop. How other applications can leverage this data and access it using other protocols like NFS, HTTP. Ketan, hold your question for some time. I think it will need some more time. I need to give you few more insights of HDFS before that. It will need almost half an hour or 45 minutes. So I think in the HDFS, after showing you the complete picture, how the data is divided, where exactly data is stored, which is the location in the data, how we can access that, or how client is exactly reading the data, then only I can answer this, hold this question for some time. Sandeep is saying, how long will we continue? Oh, Sandeep will continue till, let me see the time. Oh, it's already 11. Just let's finish just 2 more slides, just MapReduce introduction, then we'll close the session. By the way, our time was still 11 only. Just give me 5 more minutes, hardly 5 more minutes. I agree guys, it's really late, but let's finish at least the introduction of MapReduce. So guys, MapReduce is a programming model designed for processing large volume of data in parallel by dividing the work into set of independent tasks. Now guys, you'll ask me, is the same copy of algorithm will go or the work will be divided? Just with an animation I'll show you the same. Oh, I think you can't see my screen. Now I think you can see. MapReduce is the heart of Hadoop. It moves computation close to the data rather than data to the computation. I'll show this everything via an animation. Hold just 2 more seconds. This programming paradigm allows for massive scalability across hundreds or thousands of servers in a Hadoop cluster. A MapReduce job split the input data set into independent chunks which are processed in completely parallel manner over the cluster of machines. So the complete thing, let me show you via an animation. So guys, till now user has stored the block in HDFS, block 1 here, block 2 here, block 3 here, block 4 here, right? And everybody can recall this. Now I'm showing you how user will process this data. User needs to write an algorithm for this. User firstly need to write this algorithm for this. This is the MapReduce job. In actual Hadoop terminology, this will be MapReduce job, where you can write your own Java code. User will submit this job to master. Look at this guys, user submit the algorithm to master. Now master will send same copy. Master will send same algorithm, complete work, complete job as it is on all the slaves wherever the data is. Look at this. One copy of MapReduce is here, one copy of algorithm here, one copy of algorithm here, one copy of algorithm here, and so on. Now guys, understand this algorithm, this copy of algorithm will process the data available on this machine. Suppose here I'm having block 1, block 7, block 9, block 11 and so on. Here block 2, block 20, 21, 27 and so on. Block 3, block 9, block 15, block 17 and so on. So here this algorithm will process the data whatever is available on this machine. All of you guys getting my point? In this manner, the same copy of algorithm is going on all the machines, but they are doing the small task or sub work, sub job, that is actually called as a task. So guys, I think we are running out of time, so let's call it a day. So let's stop for the day, and we'll take ahead from here in the next session. So before closing the session, if anybody is having any questions, any doubts? Yeah, perfectly valid question, Sandel. How will the results send back to the master consolidated? Actually, Sandel, the interesting point is that since your input data is stored here, your output data will also be stored here only. Output data will also be stored here only, and that will be available for your client. That will see actual end-to-end processing in actual MapReduce session. but actually all these things will be taken care by the framework. You don't need to even write a single line of code about this movement of data or movement of algorithm or anything. When we saying can there be more than one block on a slave system, Vineet, there will be thousands of the block on this slave. On each and every slave there will be thousands of the block. For the simplicity of figure I am showing one block. I can't show 1000 blocks here and show you the processing, right? Can you please send me the invitation? Yeah, Ketan, sure. You'll get the mail. When this is not relational, how it relate user data to one particular user? Sandeep, you can have totally unstructured data like a paragraph. Like let me show you the example. You can, if you can see like these 3 paragraphs, if you can put this data as it is in the HDFS, and suppose you want to count the word, very simple example of this unstructured data. I want to count the word, how many time programming, how many time model, how many time design is there. You can do that also, but there is an end-to-end flow, there is an end-to-end protocol that you need to follow. All these end-to-end protocol you need to actually code in a specific framework. That framework is called MapReduce. Alright guys, so if anybody is having any other questions. Okay, let me, you can mail us. By the way guys, let me share your info ID. info@data-flare.com. I have pinged you all, by the way, our contact ID, info@data-flare.com. Manish is asking how many employees. Manish, we are a startup. We recently started our operations. Sandeep saying you mean to say MB is showing us profile in FB related to US. Sandeep, actually there is a totally different system is deployed in FB. I recommend either you wait for some time. We'll discuss about how exactly it's deployed related to user profile and all. It's not really that much randomly stored. There is a very big architecture that Facebook is having that we'll discuss. If you want, we can have a session. We can. Alright guys, that's it for the day. So our next session is on I think as far as I recall